right, we're going to be taking in a reciprocal function and putting a horizontal shift to it. So horizontal meaning side to side. So we know that our parent function is y equals 1 over x, and our graph looks like this, which is called a hyperbola, with vertical asymptote at 0, horizontal asymptote at 0. All right, so when we do a horizontal shift, we start with our function f of x, and horizontal being left and right, x also being left and right, we're only going to adjust the x. So what this would look like is only adjusting the x minus h. Okay, so if I say that we want to shift right, let's say 2, that means only to the x we're going to be subtracting 2. So our new equation is going to be y equals 1 over x minus 2. So we're going to take this equation by putting x minus 2 on the bottom. That will give us a shift of right 2. So let's go ahead and graph that. Okay, by moving right 2, the vertical asymptote that is at 0 is going to move to the right 2. So we're going to have this vertical asymptote right here. And then we'll just sketch the hyperbola the same. Okay, so the horizontal asymptote doesn't change because we did not move up or down, so it just stays here, and then we'll go ahead and graph. I'm okay if you sketch, but you can do the best you can. All right, here, because we moved to the right too, that changes our domain. So let's go ahead and write out the domain and range. On the parent function, the domain from left to right had a gap at the 0, but here our gap moved. We do hit 0, we don't hit 2. So our domain goes from negative infinity to 2, not included, and then it starts up again to positive infinity. The range, we did not move up or down at all, so the range does not change. So our range goes from negative infinity to 0, and then from 0 to infinity. That's it.